You know, in the world of AI, there are some rules that are just so fundamental they basically become invisible. They're the ground everything is built on. But today, we're going to talk about what happens when that ground starts to shake.
Think about this. For almost a decade, if you were building a huge AI model, you used one specific tool to train it, an optimizer called AdamW. It was the undisputed champ, the go-to standard for pretty much everyone. So, what happens when a rule that's been in place for 8 years suddenly breaks? Well, the answer could completely change how the most powerful AIs on the planet learn, making them way faster, cheaper, and smarter than we ever thought possible. All right, so here's the game plan. We're going to start with the core problem, then get into how AIs actually learn. We'll meet our old king and the new challenger, see what happened when things went catastrophically wrong, and then dive into the brilliant fixes that led to a brand new era in AI. Okay, first up, the optimizer's dilemma. Let's dig into why, after 8 solid years, the AI world was suddenly desperate for a new way of doing things. So, first things first, what even is an optimizer? Well, in the simplest terms, it's the engine of learning for an AI. It's the little algorithm that's constantly tweaking and tuning all the internal connections inside the neural network to get it better and better at its job. And probably the best way to think about this comes from the researchers themselves. Imagine you get dropped into a massive, hilly Minecraft world, and you're blindfolded. Your only goal is to find the lowest possible point, the deepest valley. The optimizer? That's your guide. It tells you which way to step and how big of a step to take, all based on how steep the ground is right under your feet. Now that whole process, that's what the pros call descending the lost landscape. That giant Minecraft world is the lost landscape, and finding that lowest valley means finding the point with the lowest possible error. This, right here, is the absolute core of how an AI gets smarter. So here's where we can see how our two guides work differently. The old king, AdamW, is all about momentum. It's like a sprinter. If it feels the ground going steeply downhill, it just starts running, faster and faster. But the new challenger, Muon, is more like a careful hiker. Before every single step, it kind of pauses, feels the ground in every direction, and then takes a very steady, deliberate step. And that right there is the big problem with AdamW. All that momentum is a real double-edged sword. If that valley suddenly takes a sharp turn, AdamW just barrels right past it, overshooting the path. Then it has to waste a ton of time and energy just to get back on track. And you can actually see this in the data as these ugly, inefficient spikes in the learning process. So that really sets the stage for our big showdown. AdamW, the trusty but sometimes clumsy veteran, squaring off against Muon, the super careful and precise newcomer. And the early results were, frankly, incredible. On smaller scale tests, Muon's careful approach was up to 35% more efficient. I mean, it found the bottom of the valley way faster, using less energy. But the huge, multi-million-dollar question was, could it actually work at scale? Could it handle a world that was the size of a continent? And that brings us to the moment of truth. Researchers at a company called Moonshot AI, they decided to bet big. They used Muon to train their brand new, absolutely massive model. And, well, they almost immediately hit a brick wall, a really, really big one. So here's what went catastrophically wrong. Right at the beginning of training, some weird data points created this giant, totally incorrect signal. Now, AdamW would have mostly ignored it, but Muon's special feature, spreading the learning out evenly, became its Achilles heel. It took that massive error and smeared it across every single part of the model. This created this insane, vicious feedback loop where each mistake made the next one even bigger, until the whole training run just collapsed. So there they were, with their entire project about to go up in smoke. They had to literally invent their way out of this mess. And that led to some amazing breakthrough fixes that not only saved their model, but ended up perfecting Muon for these massive jobs. They came up with 3 really clever ideas. First, something called Muon Clip. It's basically a ceiling that just chops off any ridiculously huge calculation before it can poison the whole system. Second, they added weight decay, which is a way to keep the model's numbers from just exploding over time. And finally, update scaling, a smart rule to make sure the learning steps stay nice and consistent across the whole model. And the result of all that hard work? Well, in the researchers' own words, it was an absolute beauty of a training loss. A perfectly smooth, stable, downward curve with zero of those ugly spikes. I mean, this beautiful line cost them $20 million to create, but thanks to their fixes, it was a massive success. And that success wasn't just about a pretty graph. No, it led to the birth of a new, incredibly powerful AI model they named Moonlight. And this is where we see the real game-changing impact of this new optimizer.
When you boil it all down, it comes to one number, roughly 2 times.
What does that mean? It means Muon is about twice as computationally efficient as the old standard, AdamW. To get the same result, you only need about half the computing power. I mean, that is an absolute game changer in this field. And here's the visual proof right from their paper. You don't have to be a data scientist to get this. The blue line, that's Muon, is always below the red line, AdamW. That means for any amount of computer power you throw at it, that's the line on the bottom, Muon gets a better, lower error score. It's just flat out more efficient. And the performance numbers, they just speak for themselves. This is Moonlight, trained with Muon, up against competitors trained the old way. Yeah, it's better on general knowledge, but just look at the hard stuff. On reasoning, it's scoring in the mid-60s, while the others are in the 40s. On coding, a 48 versus the high 20s. And on math, it's not even a competition. It's a complete blowout. This shows what that extra efficiency really unlocks. So let's wrap this up. A huge 8-year-old rule in AI has just been shattered, and the result is a new method that's twice as good. It really makes you stop and think, right? If our most powerful tools can suddenly learn twice as fast using half the resources, what kind of impossible challenges are we going to be able to solve tomorrow?